Okay, this is a video for Math 105. I plan to work through the group activity for section 3.1. You can find the blank worksheet in the week 9 other materials site, so you might want to work on that first before you watch this, but that's up to you. Okay, so let's say we have a function here. It's a quadratic function. F of x is negative 4 times x squared plus 8x minus 9. So that's in what's called general form. Right, y equals ax squared plus bx plus c. So determine the vertex. Now remember, the vertex is this point hk in standard form. Where the connection between this and this is h is minus b over 2a, and k is what happens when you plug in h to the function. Okay, so let's do that. So in our case, h is minus b minus 8, because b is 8, all over 2 times a minus 4. So this is very easy. It's just 1. And now k is what happens when I plug in 1. And so that's minus 4 times 1 squared plus 8 times 1 minus 9. So that's negative 4 plus 8 minus 9. That's positive 4, that's negative 5. So I'll write it up here. The vertex is the point 1, comma, minus 5. Woohoo! Okay. On to part B. Without graphing, is the vertex a maximum or a minimum? Well, we need to know, does the parabola point up or does the parabola point down? Remember, it points up if a is greater than 0. It points down if a is less than 0. In our case, a is negative 4. So we have this, which means the vertex is a maximum. Because it points down. Okay, what's the range? Well, again, since it points down, it can go down as far as you want, and it can go up to as high as whatever k is, minus 5. So one way to write that would be say x is less than or equal to minus 5. But we want to use interval notation. So in interval notation, how we write that is, you can say we can go anywhere from minus infinity. Again, this is round brackets because minus infinity is not a number. It's just an idea. It's sort of the left arrow. We can get as high as negative 5, and we can get to negative 5. So you have to put the thing there. That's the sort of equals part. Okay. I didn't write it, but note that the domain, it wasn't a question, but the domain is all real numbers. And that's because that's the domain for every polynomial. Okay, now rewrite f of x in standard form. Well, the a stays the same, so that's minus 4. And we need to know the h and the k, but we figured out the h and the k. So here's important, it's x minus h. So if h is negative, it'll be x plus. But here h is positive, so it's x minus 1. And then here it's either whatever k is. and k is minus 5. Okay, so this is standard form. This is general form. And now, how would I, using transformations, right? So if let's think this through. If I start with the standard one, y equals x squared, how would I turn that into this? Well, I would have to flip it, stretch it, move it to the right by 1, and move it down by 5. So I'd have to reflect over x-axis. I'm sorry, yeah, over x-axis. Turn it upside down. I'd have to stretch or dilate, stretch vertically by 4, by factor of 4. I'd have to shift right 1, and then the last thing you do is shift down, up or down, shift down 5. So basically, it's flipped upside down, it's stretched really wide, so like this is 1, 1. It's moved over here and it's moved down 5, 3, 4, 5. And then it's stretched 1, 2, 3, 4. So it's really skinny. It's a bad thing. And of course you could go on to decimals or whatever and see what the graph looks like. Okay.